In this video, I'm going to explain heat capacity. I will start with a question. Here you see two blocks. They both have a temperature of 20 degrees Celsius and are made out of the same material. Which block heats up fastest? Pause this video to write down your answer in your notebook. Each molecule needs to absorb an amount of heat energy to increase its temperature with, say, 1 degree Celsius. So the more molecules, the more heat energy is needed to increase its temperature with 1 degree Celsius. So when both blocks absorb the same amount of energy, the small block will have a bigger temperature rise. In other words, the small block will heat up fastest. You could also say the smallest block because there are less molecules in this block. Let's see if this is clear to you. Another question. Again, we have two blocks. This time they both have a temperature of 30 degrees Celsius. Now, which block needs more energy to heat up 1 degree Celsius? Pause this video to write down your answer in your notebook. Let's see. The bigger block, because there are more molecules in this block. So this block needs more heat energy to heat up 1 degree Celsius compared to the small block. Another example. A swimming pool has a bigger heat capacity compared to a glass of water. This means that if you want to increase the temperature by 1 degree Celsius, you need much more heat energy for the swimming pool than for the glass of water. But also the other way around. When the temperature drops by 1 degree Celsius, the pool releases much more heat energy compared to the glass of water. In physics, we use the quantity heat capacity. Heat capacity is the amount of energy, in joules, needed to raise the temperature of a material by 1 degree Celsius. The abbreviation is a capital C, and the unit is joules per degrees Celsius. Heat capacity can be calculated when you know the heat energy and the temperature rise. We use the quantity heat energy, which we abbreviate with the letter Q, and the unit is joules. Also, we use the quantity temperature difference, which we abbreviate with delta T. Make sure it's a capital T, and the unit is degrees Celsius. So with these quantities, you can calculate the heat capacity. It's the heat energy divided by the temperature difference. Now, how would you rewrite this formula in such a way that you can calculate the heat energy in joules or the temperature difference in degrees Celsius? Pause this video to write down your answer in your notebook. So, if you want to calculate the heat energy in joules or the temperature difference in degrees Celsius, you can rewrite the equation. And this is what you will get. So, let's take this new knowledge into practice. You put some water in a cup. The heat capacity of this cup with water is 420 joules per degrees Celsius. How much energy do we need to heat up the water so that the water rises 5 degrees Celsius? Pause this video to write down your answer in your notebook. Let's see if you were able to find the correct answer. First of all, I wrote down all the information from the text. The heat capacity is 420 joules per degree Celsius, and the temperature difference is 5 degrees Celsius. And the heat capacity is what we need to calculate. The formula or the equation I'm going to use for this is Q equals C times delta T. Then I fill in the numbers. 420 times 5 equals 2,100 joules. So this is the amount of heat energy needed for the water to rise with 5 degrees Celsius. Now you've got an idea of how to use heat capacity in joules per degrees Celsius.